Now, coming to the next part of these machines, the terms related to machines. Terms related to machines. Terms related to machines. Okay. फर्स्ट वन, ये लोड क्या है? लोड को डिफाइन करेंगे. वी हैव टू डिफाइन द लोड. सो the resistive or opposing resistive or opposing force to overcome by a machine is called लोड. उसको हम लोग लोड बोलते हैं. सो resistive or opposing force to overcome by a machine. Just like you need to basically remove some amount of weight. So that weight you need to pick or something, slide or something. So that weight is actually your load. Next, what do you mean by effort? Because in every machine, every time we have to consider load, effort, that concept. So the force applied on the machine, the force applied on the machine to overcome the load, to overcome the load is called effort. We'll denote it by E. दैट मीन्स द लोड. तो ये लोड था, तो लोड को ओवरकम करने के लिए जो हमको देना पड़ेगा, अप्लाई करेंगे हम लोग बेसिन के ऊपर, दैट इज एफोर्ट. सो एफोर्ट इज applied by us on machine, and the load is the machine which the machine is basically overcoming the opposing force. And here comes a very important terminology. It is known as mechanical advantage. Mechanical advantage, which is nothing but denoted by MA. It is equal to load by effort. Load, that is output, by effort is input. Load by effort is actually your mechanical advantage. Now here are such conditions, like if your mechanical advantage, if it is greater than 1, then what type of machine? Mechanical advantage is greater than 1 means, you see, mechanical advantage is nothing but it is ratio of load to effort. So you have a fraction where the numerator is load and denominator is effort. Now if this is the fraction, a mechanical advantage, now if you consider this to be greater than 1, that means your load has to be greater than effort. That means you are applying less effort to overcome more load. That means effort needed is less. Okay, so the effort needed is less than the load. Another condition, mechanical advantage is equal to 1. That means the effort needed equal amount of load. That means the effort needed equal amount of load to overcome. Then mechanical advantage less than 1, less than 1, less than 1 means the effort needed is much more greater than load. The effort needed is greater than load, greater than load. Now in this case where this mechanical advantage is less than 1, this type of thing we are saying it is velocity, what we can see it is velocity gainer, speed gainer, gain in speed. Okay, so where mechanical advantage is less than 1 because the effort is more needed than the load, then it is known as, here what will happen, there will be gain in speed, gain in speed in the machine, gain in speed. Whereas mechanical advantage greater than 1 will give you, gain in force, that means force multiplier, force multiplier, that means suppose you need to overcome 200 Newton load. Only you are giving 20 Newton effort. So 10 times you are basically getting the result. So that is why mechanical advantage is greater than 1 is known as force multiplier. But is mechanical advantage less than 1 is basically gain speed. And when there is equal, MA is equal to that 1 equal to 1, that means load equal to the effort, equal load for equal effort, or equal effort for equal load, then it is used to change the direction of the effort. This will be used to change the direction of the effort, to change the direction of the effort, direction of the effort. तो एफोर्ट का डायरेक्शन चेंज होता है, लेकिन ऐसा नहीं कि फोर्स भी मल्टीप्लाई नहीं होगा उसके लिए, और दूसरा कुछ ऐसा भी नहीं होगा कि वेलोसिटी मल्टीप्लाई हो रहा है, लेकिन उसमें क्या हो रहा है, डायरेक्शन चेंज हो रहा है. सो दैट इज योर मैकेनिकल एडवांटेज इज इक्वल टू 1 का केस. So these are the cases for mechanical advantage. These are the cases for mechanical advantage. Now we should follow another term which is known as velocity ratio. So mechanical advantage is one term, another is velocity ratio. Velocity ratio is another term. What do you mean by velocity ratio? It is defined as the ratio of the velocity of effort, the ratio of the velocity of effort to the velocity of load, to the velocity of load. So velocity of effort by velocity of load is known as velocity ratio. So what we can write, VR, velocity ratio, is equal to velocity of effort by velocity of load. Velocity of effort by velocity of load. Now we can do one thing. We know velocity is nothing but distance by time. So V can be written as distance of the effort by time. VL also distance of the load by time get cancelled. So what you will be having, you'll be having distance traveled by the effort by distance traveled by the load. So that also can be used. If you don't have the velocities, then with the help of distance also, distance of the effort by distance of load is nothing but velocity ratio. So this is how you can define velocity ratio. Now in the velocity ratio also, the same like mechanical advantage, the conditions are there. So velocity ratio when equal to 1, okay, then what you can say, like the same mechanical advantage, it doesn't change the force or displacement, it basically change the direction. In this condition, when equal to 1, machine changes the direction of the effort. Machine changes the direction of the effort. That is velocity ratio. Now, if this VR is more than 1, then the same concept, it works as a force multiplier. So VR is greater than 1, it works as a force multiplier. It works as a force multiplier. Next, so when VR is greater than 1, like the mechanical advantage, it works as a force multiplier. And uh, this is one condition. Another condition, so definitely if it is less than 1, then it is basically uh, it has the same effect like the mechanical advantage. But the thing is that if we consider the unit of velocity ratio and mechanical advantage, in both the cases their units, there doesn't have any unit because they are the ratio of same quantity. You just consider mechanical advantage, there it is the ratio of effort, you can see, sorry, load by effort, that mechanical advantage, you see that case. So mechanical advantage, sorry, is there, mechanical advantage, you see it is load by effort. Now load is also force, effort is also force, so force by force, so it is unitless. Similar for velocity ratio, velocity of effort by velocity of load, so both of them are velocity, so ratio of the same quantity will give no unit. And then definitely the distance traveled by the effort and distance traveled by the load, it is also the ratio of the same thing. Now the efficiency, first we need to define efficiency. We need to define efficiency efficiency. So it is the ratio of, is the ratio of, is the ratio of the useful work done, useful work done by the machine, by the machine to the work put into the machine by the effort, put into the machine by the effort. Now Simply what you can say, it is the ratio between the output and the input. Input is effort, output is the load, whatever is there. So the same again, doesn't have that unit, but what you need to do, multiply with 100 you need to do. So it is denoted by eta symbol, eta, this is eta efficiency, that is work output by work input, work output by work input. So I can write W output by W input. Okay. And then what you have to do for getting the efficiency, you need to multiply it with 100. Okay. Again, it doesn't have any unit. Okay. So this is about the terminologies frequently used in machines.